Okay, now this problem is similar to the first one, but I think it might have a different inequality sign. But we first look for our keywords that tell us what numbers go where. So it says Debbie has at most $60 to spend on clothes. Okay, so that's the total that she can spend on clothes. She wants to buy a pair of jeans for $22 and spend the rest on t-shirts. Each t-shirt costs $8. Okay, so that 22, how many times is she paying for that? That's just a one-time fee. It's just a pair of jeans. So that's going to be the number that's by itself. It's just a one-time fee. But then she says she wants to spend the rest on t-shirts. Each t-shirt costs $8. So I know that that 8 is going to be the number with the variable because it has that keyword each, which tells me it's multiplied by x. That's the one that's going over and over and over, kind of like the slope. So I'm going to write out my numbers in their order. I have 22. Okay, that's the one-time amount. But then I have 8 that's being multiplied by x. Okay, now I don't know what sign goes here, but I do know my total on the other side. My total is $60. Okay, that's the amount that she wants to spend. But not exactly the amount she wants to spend because it says Debbie has at most $60. Okay, so the sign that I'm trying to figure out is at most $60. Okay, so I have $60 over here. And I need to think of numbers that it could be if it's at most $60. So at the most she could spend is 60. So she could spend 40. She could spend 55. We need to figure out, well, can she spend 60? That's the most she could spend. She just can't go over it. So 60 is included. Okay, now when we're writing our sign, we look to see, is that 60 over here? Is that repeated? Yes. The 60 is included in the list, so my sign's going to be underlined. And all the numbers to the left are less than 60. So my sign is going to be less than or equal to 60. So the at most sign that it's using in my problem is less than or equal to. So the way that my equation reads is 22 plus 8x is less than or equal to 60.